So let's look at another example of using direct comparison test. Here we have an integral from 3 to infinity, and the function involved here, our integrand, is very, very close to being 1 over square root of x. And remember, that's 1 over x to the half. So that is one of our reciprocal power functions. So you might think, okay, well, let's do direct comparison with 1 over square root of x, and you'd be right. Now, we have to think about a couple of things. Remember, the functions need to be continuous. So let's think about these two, 1 over square root of x minus 1 and 1 over square root of x. This guy would divide by 0 when x is 1, and this one when x is 0. But we're starting at x equal 3 and going to infinity, so no problem there. So those are both continuous on our interval. And subtracting 1 on the bottom makes that denominator a little bit smaller. So this denominator is smaller than this one. And so remember that a smaller denominator means a bigger fraction. So in terms of our inequality, first of all, 1 over root x is greater than or equal to 0 for sure. But it's also less than or equal to that on our interval. OK, so now we have everything we need. We're actually going to use part 2 now here, about divergence, right? Because what have we just shown? That these two guys are both continuous, and the one we're interested in is larger than 1 over root x, and that integral we know diverges. So we're bigger than a divergent. So since the integral from 3 to infinity of 1 over root x dx diverges, and again, I want you to say why we know that, and all you have to do to show me you understand is to say, well, I know it's based on that exponent, which is a half. And the decision is that if that comes out to be less than or equal to 1, we know that that reciprocal power function, that integral there, is divergent. Then we have everything we need by DCT. They're both continuous. This unknown one is larger than this one that we know, which is divergent. So then that means that the integral from 3 to infinity of 1 over root x minus 1 dx diverges by DCT. All right. Now, the only problem with this is if this inequality is the wrong direction. If this had been plus 1, we'd still suspect that this is divergent. I mean, plus 1, minus 1, what's the difference, right? But plus 1, this would not be bigger. It would actually be smaller than our divergent, which is not the direction we need the inequality be to make that argument by DCT. So another way we can approach these is don't argue based on who's bigger or who's smaller, but how fast they're running down to 0. And to do that, we'll compare their growth rates or the limit of their ratio. And that's what we call limit comparison test, which we'll look at next.